All right, geometry, let's take a look at our next set of notes from 1.3, the look and language of logic. So let's start out by writing some words that come to mind when we think about logic. So let's pause for a moment and write these together. So maybe you think about things that means like things that are reasonable or making sense of something or putting things in order, right? Something along those lines. Maybe you came up with some of those. All right, so let's take a look at this Venn diagram and see what we can talk about for looking at logic, okay? So we have 10 items to put in this Venn diagram. And all a Venn diagram is an organizational chart that puts different objects into different categories, right? Okay, so I have a orange. So it looks like it is a fruit, right? So maybe I could put it right here and write the word orange. Or what else? Could I put it in here? No, because it's not an orange, right? That's for apples. So I'm going to go and write orange right here. Okay, so that's where orange goes. Okay, let's go and see for pear. We'll make that a lovely green color. So is a pear a fruit? Yes, it is. So I could put it in here. Is it an apple? It is not. So it doesn't belong in here. And it stays right there. Okay, how about a lemon? So lemon is yellow. Okay, so is a lemon a fruit? It is. Is it an apple? It is not. So again, it's going to go in this section right here. Okay, all right, let's take a look at the next one, a ball. So let's make that a brown color. Okay, so is a ball a fruit? No. Is it an apple? No. So it doesn't go in either one of those circles. So where does it have to go? It has to go on the outside somewhere. So the ball goes out here somewhere. Okay, all right, let's try apple. So for an apple, so you could just be writing these words in these spaces. Okay, so for an apple, is it a fruit? It is. Is it an apple? It is. Okay, if I put an apple here, I am saying that it is fruit, but it is not an apple. And that's not true. It really is an apple. So the apple belongs here and not over here, right? Because now we are saying it is within the fruit circle and it is an apple. So it's in the right spot. It's in the most accurate spot. Okay. Let's go and check a cup. So let's go do a cup. Okay, is a cup a fruit? No. Is a cup an apple? No, so it goes up here. Okay, and let's see what else we've got. Let's do a banana. I'll make this one gray because I already used yellow and orange. All right, so is a banana a fruit? It is. Is it an apple? Nope. And we have a cherry. We'll use purpley color for that. Cherry is not an apple, but it is a fruit. It goes up here. And then a dog. A dog, we'll make that one black. A dog is not an apple. It's not a fruit. It goes on the outside as well. Now, believe it or not, we just did some logic. We thought about some logic and we go, is this item this? Yes. Is this item this and that? Yes. So when we put an apple in here, we are saying that it is an apple and it is also a fruit, right? When I put something in here, I am saying it is a fruit, but not an apple. And when I put something out in this section on the outside, I am saying it is not an apple. All right, so if I'm calling something an apple, then it does belong into the outer shapes of fruits, and then the other shape that maybe it's just called objects, right? So maybe these are just called objects. Okay, so if we call something a fruit, it's still also the outer shape as well. It's also an object, okay? But if an item belongs only to the outer shape, like if we're only doing objects, it may not belong to the smaller shape, right? So we have some, we have a cup over here, we have a dog, that didn't belong in either of the smaller shapes, right? All right, so what I'd like you to do is I'd like you to come over to here and I would like you to practice. So find the practice one And I'd like you to pause for a second with your class and let's see if you can put all of these words in the right places. So where would soap go? Where would salty go? Where would sandy go? Where would windy go? And knowing that in the first diagram, it says if the word starts with an S, then it ends with a Y. Okay, so in the middle, it says words that start with an S, and then out here, it says words that end in a Y. So does soap go in the middle? Is soap a word that starts with S and also a word that ends in Y? And the answer is no, soap doesn't go in either of those. It would go on the outside. Okay, what about salty? Salty. Let's see, does it start with an S? Yes. Does it end with a Y? Yes, it does too. So salty belongs here. Okay, all right, let's go check sandy. So if we're looking at sandy, does it end with a Y? Yes. Does it start with an S? It does. Okay, and then windy, let's go check that one. So windy, does it start with end in a Y? Yes. Does it start with an S? No. So it's going to go in this little section right here. Okay, so where do we put soap? Because these two circles, the outer circle, the one that holds all the other stuff on the inside, has to end in a Y. Soap does not end in a Y, right? But it does start with an S. But the words that start with S right here have to be part of that other bigger world right here. So soap belongs all the way on the outside. Okay, it's not really part of this picture at all. All right, let's go do the same thing over here. Okay, so on this one, we have diagram B is some words that start with an S and end with a Y, but now they've done it a little bit different. Instead of putting a circle inside a circle, they gave us some room in between the circles. So let's again start with soap. Is soap a word that ends in Y? It is not, so it cannot be in the circle that says it ends in Y. The other one says it starts with S. It can go in here, so I could put it here or here. Which one is the right space? Right? I don't want to put it in any part of the circle that ends in Y. So I'm going to take it out of there, but it does go over here, which is just a part of the one that starts with S that doesn't end in Y. Okay, so let's go try salty. Salty ends in a Y. It starts with an S, so it goes in here. Right? It goes in the overlap, so it's part of both circles. All right, next one. What about sandy? Where should we put sandy? Okay, how about here? Right, it also starts with an S, ends with a Y. Okay, and then lastly, windy. Windy ends in a Y, starts with an S? No. Ends in a Y? Yes. So this time, it will go up here. Cool. All right, so that's how we fill out diagrams, and we're using logic to think about whether it belongs in that group or not. Okay. Are these two groups logically equivalent? Well, they don't look equivalent, they don't look the same, so I'm going to say no. And why do you think that is? Why aren't they equivalent, right? The biggest reason that they aren't equivalent is because soap had nowhere to go. Soap didn't belong to any circle. To any circle in diagram, what was that called? Diagram A. But it does in diagram B. All right, cool. All right, so let's go back and now we're going to practice some other type of logical thinking. So we're going to go right back up to here. All right, and let's take a look at this one next. So on this one, we're going to be filling in the blanks of our conditional statements. Now remember, we've already talked about conditional statements about an if-then statement, right? So we've talked about that when we talked about deduction, right? So if it's this, then it must be this. Okay, so in an original conditional statement, we have to accept it as true because that's how it's originally presented. So that's usually if A, then B. And remember, anything can be represented in A and B depending on the circumstance. So right now we're just looking at those two letters, A and B. All right, so that's the original statement. That's our first statement that they give us, right? Okay, our next statement that they're going to give us is, can you figure out from the original, here we go, original. Can you figure out from the original what its converse is? So in a converse, what happens? So in a converse, another way to say converse is, where did I put that paper? I want to make sure I get this right. Okay, so in a converse, we're just going to reverse the original A and B. So we are going to reverse the clauses. So we're going to say if B, then A. So that's for converse. Okay, so if I say, what is the converse of if A, then B? You say it's if B, then A. Okay, let's go on to the next one. What about the inverse? So the inverse is going to be if not A, then not B. Still in the same order, A first, then B, but an inverse puts them all into nots. Okay, so they put them all into knots. So we are doing negating or negatives. So it negates each clause with the original. Okay, and then our last one right here, the contrapositive. So in the contrapositive, we're going to do one of each. We're going to reverse and we're going to negate. So that's going to be a not for the negate, and then reverse is going to be B and not A. So that's a contrapositive. Good. All right. Let's see if we can do that with an actual example and work together, and we'll pause in between as a class. All right, here we go. So in the original, if a thing is an apple, then it is a fruit, right? So we're just basically labeling these for a quick second. This is the A, this is the B. Apple, fruit. Okay. So for shorthand, they're going to write it A and F, apple and fruit. Fine. Okay, and we say that's automatically true. Whatever the original one is, we're going to assume it's true. All right, so the converse would be if a thing is, what did we do? We reversed it, right? If the thing is a fruit, then it is an apple. So we're going to say if F, then A. So we're going to reverse it. Okay. Now let's actually evaluate that sentence and see if it makes sense or if it doesn't make sense. If we know something is a fruit, do we automatically know it's an apple? No, it could be another fruit like a pear or banana, right? So that is a false statement. Do we agree the first sentence is true? If the thing is an apple, it's a fruit. Yes, an apple is a fruit. An apple is a smaller category of the bigger category called fruit. All right, let's try the next one, inverse. So remember, in inverse, we just negate it, right? We bring in nots. Okay, so if the thing is not an apple, then it is not a fruit. So we're going to say not. We're going to say not. How do I say not quickly in shorthand? So I'm going to say A first and then F, and then the shorthand for not is this in front of it. It's just kind of like a little part of a rectangle or a square, like the little top right hand corner, like that. Okay, so not A, not F. All right, and then the last one, let's go look at it. It is contrapositive. That means we do a little bit of each, and then we'll go back and figure out the trues and falses. So if not a fruit, then not an apple. Okay, so let's go back to the blue one, the inverse, and see if we can come up with whether that's true or not. If a thing is not an apple, so think of anything that's not an apple. I'm thinking of a pear. Then it's not a fruit. Well, that's not true. A pear is a fruit, so this is false. Oops, let me turn it back to blue. This one is false. All right, let's try the next one. If the thing is not a fruit, then it's not an apple. Okay, not a fruit. A dog. A dog is not an apple. That seems true. Okay, so how do we write this one? This one's going to be not F and not A. Okay. All right, so we've got that part down. So we need to be able to recognize original, converse, inverse, and contrapositive and be able to write those sentences. Okay, that's one of the things that we want to be able to do for this class, for this section. Okay, all right, so next part is, let's go and do syllogisms. Okay, so a syllogism is a chain of conditional statements. So a chain means lots, right? Okay, so give an example. So here's an example. If X means Y and Y means Z, then X must mean, they use the word implies. So if X implies Y and Y implies Z, then X implies Z, right? So it's almost like this. Let's say I'm X and I say, hey, Y is my friend. So X and Y are friends, but I don't know Z, but Y knows Z. And Y says, hey, I'm friends with Z. And since I'm friends, we're going to all be friends. So what happens? You know what that happens. When you have a friend in between, you end up in the same group, and now you're all friends. Okay, so now I can say I know Z and he's my friend too. All right, so showing the shorthand. If X arrow Y and Y arrow Z, then X goes all the way to Z. And in a Venn diagram, we can look at that one as well. Okay, so if I look at the Venn diagram, if I know X and X knows Y, then X knows Z, right? I'm going and saying I'm part of all of those groups, and Z is the outer layer of that group, right? That's my friend's friend, okay? All right, so what are we gonna do with this practice? Let's go see if we can find something. So it says, how does diagram A show that this conjecture is false? And that is all we have left on notes, you guys. So let's go do this, okay? All right, sorry, making you dizzy, I know, hang on. All right, so we are back to the idea of putting all those words into those two diagrams. And it says, how does diagram A show that this conjecture is false? Well, if a conjecture is false, why would it be false? Show that the conjecture is false. So the conjecture was, if a word starts with S, then it ends with Y. So if a word starts with S, so if I start in here, I should be able to go out here and create more words that still work, right? So salty is a word that starts with S, but it also ends in Y. That's why it goes into both circles, right? Okay, so we have the word soap though, that doesn't fit. Soap isn't a word that it is a word that starts with S, but it doesn't have anywhere else to be, right? So we have to say that that conjecture is false. They already said it's false. How do I say that? We have to say something about it's false because, let me change colors here. It's false because we have nowhere to put, nowhere for soap. Okay, and then in our last one right here, does diagram B show that the conjecture is true? How does it show that it's true? And it shows that it's true because, so this diagram over here goes with this phrase really nicely. It matches the phrase that we're trying to say. So this makes us happy. Why? Because we're able to fit all the words in. This one makes us sad because they gave us a rule, they gave us a diagram to go with it, and we couldn't fill it all in. So that's what makes it false. Okay, so how does diagram B show that its conjecture is true? We could say that every word had a place. And that makes us happy. And that's how we're going to end today. Happy.